Kia hora te marino, kia whakapapa pounamu te moana. Hei huri ahu mātou tue rangi nei, aroha atu, aroha mai, tātou ia tata katoa, hui e, tai kie. Well, kia ora koutou, welcome everyone. We've had a massive amount of interest in this webinar today, which is fantastic. And I would take from that it means that, you know, the concept of research impact is such a topic of priority and interest at the moment. So want to say a massive thank you on behalf of the iPEN team to Sarah, Barry and Gerald for agreeing to speak to us all on this. They are going to be talking about what does research and science impact mean for them and how they support it. And so with that, I'm going to stop talking, hand over to Sarah, who's going to do a quick round of introductions, and then they'll run through their presentations. Questions into the chat, and we'll look at those at the end of their presentations. Over to you, Sarah. Thanks.
Kia koutou katoa, ko Sarah Meadows toko ingoa, he kai whakahare te tīma Science Policy toko tuna mahi. So I'm Sarah Meadows and I'm the manager of the Science Policy team here at MPI. And I'll quickly hand over to Barry and then Gerald to introduce themselves and then we'll launch into it. Barry.
Morena, everybody. My name is Barry Wards. I'm a principal advisor within the Office of the Chief Departmental Science Advisor within MPI. And I sort of broadly cover the areas of biosecurity, animal welfare, and food safety. And over to Gerald.
Yes, kia ora, Gerald Rise. I'm the second principal advisor in the Office of the Chief Departmental Science Advisor. There are three of us, the Three Musketeers we call ourselves, and I cover the area of largely agriculture and climate change. Welcome, everybody.
All right, I will just quickly share screen. Everything should be loaded up. Perfect. Let's see here. And share.
Beautiful.
Okay, all good? Perfect. So as I said, I'm Sarah Meadows and I manage the science policy team here at MPI. I've been involved in the science policy space for about 11 years now on various bits and pieces. But today I'm going to be speaking about science impact and policy, particularly in an operational setting. There we go. So before we get into the more operational stuff, I'm just going to do a quick sales pitch for the team. So Science Policy is situated in the Strategy and Insights Directorate of Policy and Trade at the Ministry for Primary Industries. We have a focus on science for policy, on policy for science, and science system relationship management. And we're increasingly focusing on things like proactive advice on topical issues, for example, diverse proteins and biotech, and trying to front foot some of the issues as opposed to being in a reactive mode. But in terms of why I'm here today, we are going to be talking about operational strategic science plans that we developed across a number of areas. So when asked to present in this, I think the best example of kind of where we've got it right is our strategic science plans that we developed roughly from 2018 to 2021. These were developed on areas of kind of topical interest. From a process perspective, the general approach was to establish a strategic science advisory group, or SAG. So you'll hear me refer to SAGs as we move through the conversation. And these are comprised of national and international experts and key MPI science staff. We would then hold large inclusive workshops with subject matter experts, so we went quite broad to identify and prioritize research needs across particular areas. The SAGs would then either direct the drafting or oversee the drafting of strategic science plans that outline specific kind of actions in thematic areas. And importantly, with these plans, all of the actions were costed, and plans weren't drafted unless there was either allocated funding or a high likelihood of securing funding in future. So over 4 years, we developed 4 different science plans across the areas of coat dieback, myrtle rust for the 1 billion tree science program, and in Mycoplasma bovis. And we estimate that this translated to roughly $130 million in direct and aligned investment across those 4 topic areas. Because I spent the better part of 2 years working on the Mycoplasma bovis science program, I thought it'd be best to do a deep dive there. So briefly, for those of you who may not be familiar, Mycoplasma bovis, or M. bovis, is a bacterial disease that can cause mastitis, pneumonia, and arthritis in cattle. It can basically be transmitted through just about any bodily fluid, and cattle can actually carry bovis without displaying any symptoms. It was first detected in New Zealand in 2017, and in 2018, government, Dairy New Zealand, and Beef and Lamb jointly committed to eradicating the disease from New Zealand. And they did this under a government industry agreement partnership. So you hear me reference GIA a little bit going forward. So that is Dairy New Zealand, Beef and Lamb, and MPI all basically agreeing to fund the eradication. While New Zealand has historically been free from bovis, it's actually endemic in most other parts of the world, meaning we needed a lot of New Zealand-specific research on detection, surveillance, and eradication. So in following the kind of aforementioned SAG process, we set up an M. bovis SAG and included a few heavy hitters such as, Nigel French on the epidemiology space. We had Sean Hindy in terms of social and economic impacts. We had Axel Heiser from AgResearch from an animal health perspective, and it was chaired by our Chief Departmental Science Advisor, John Roach, who was also a reporting line up to governance. Governance was the 3 chief executives from Dairy New Zealand, Beef and Lamb, and MPI, and it had an independent chair. So as with all of our science plans, we needed a simple goal. And for bovis, it was to accelerate the eradication of the disease from the country. Led by the SAG, we held a 2-day workshop with the sector to identify and prioritize research needs. These were then drafted into a science plan with discrete actions, and it was agreed in principle by bovis governance on the 24th of December, 2018, which meant a decent chunk of the team spent their Christmas Eve hassling ECs and Cs and finally getting it over the line, and I had to pay for it in drinks after the fact. So that was sort of the what, which is actually the easier part. The how was a bit more complicated. So in terms of how we deliver for any piece of work, it's incredibly helpful to have guiding principles that you can refer back to make sure you're staying on course within a program, particularly in an operational space. In the case of the M. bovis science program, we developed the following principles and their meaning within the context of the program. So first, to be responsive to governance and evaluating the utility of science and tools and technologies that are being developed as part of it. Partnership, so working in partnership with our GIA partners in particular at all stages of the program and across all of its projects. Remaining focused, so on impact and on continuous improvement and the well-being of everyone impacted by the response, recognizing it was a response that didn't just impact animals, it impacted people as well. Being agile and able to change direction as needed, and importantly, being responsible. So in management of the science spend, recognizing its public funding, trying to ensure that duplication of research is avoided, and in the contractual process, embedding kind of stop-go points. So if there was a piece of work that wasn't delivering quite what we needed, we were able to wind down quickly. Further, in terms of the how, it's really important to look after your authorizing environment. And for us, this was working incredibly closely, not just internally, but with Dairy and Zed and Beef and Lamb. I think as government, we're often quite used to consulting or testing things, but we're still on a bit of a journey when it comes to co-design and co-delivery. So although the science policy team was responsible for the secretariat of the work and driving it at all stages from identification of priorities to oversight of programs, we partnered with the GA partners. So they were on the table for developing the research questions, procuring those, evaluating proposals, and then in terms of the next steps and uptake. We also regularly checked in with the SAG to make sure that we were holding true to the original document of the science plan, kind of recognizing that once we started procuring research, there were conflicts of interest that needed to be managed, such as the nature of science in New Zealand. Reporting. So I recognize reporting can be a massive pain, and I'm cognizant of my audience and want to acknowledge in many instances there are many and duplicative layers of reporting. However, it is absolutely mission critical for building trust and looking after kind of your decision makers in your authorizing environment. So for bovis, we developed a number of reporting mechanisms about communicating very technical topics in simple terms to non-technical audiences. We ensured we were always able to tie each piece of work back to the theme, the project, and the overall goal of eradication. And reporting mechanisms are regularly updated so that we could track progress over time. And then, of course, we provided these to the bovis governance group, and they were incredibly well received, so much so that we kind of became a bit of a darling of bovis governance because we always knew where we were at any given point in time with our program. This is just a further example of that. So taking a deep dive at the epidemiology space, and again, trying to keep it really simple and high level. What is the purpose? What are our intended outcomes? How far along are we? How much is it costing? And when are we going to get it? Again, the key is consistency. So at any point in time, we're able to communicate to various decision makers, be they scientists, chief executives, or ministers. This is what we're spending things on, and this is where we're going to get the output of it. Looking explicitly at impact, kind of following the outline process, obviously we've involved the key people from the outset, but we've also involved them in determining where things are going to be taken up and how they're going to be used. Often with decision makers, be they chief executives or ministers, you really need to tie absolutely everything back to how it will be used, who's going to be using it in a way that makes sense. If they're able to join the dots from A to B to C in terms of their investment, you're much more likely to kind of get that level of trust, but also secure future funding. So for example, latent class analysis, which is quite technical, and I don't think there are too many generic decision makers who understand what that means, but that's okay, because at any point in time, we were able to communicate that it's intended to be used by program epidemiologists, and that where we are now actually tells us that our current testing regime is appropriate for establishing freedom from disease. So we're able to feed that that science advice and that complicated evidence base back to decision makers kind of in real terms. It's a little bit more complicated when you get into the social science space and some of the softer sciences. Admittedly, it's not always a direct linear relationship, but you've got to do the best you can in terms of articulating what is this and who's going to be picking it up. So, for example, the farmer experience study, which was looking at what is the impact of the program on farmers and their well-being, we made sure that we were able to articulate that as a first port of call, it was going to be provided to a review of the broader Bovis program and serve as a key point of information for impacts on farmers, and then ultimately to give it a home within Biosecurity New Zealand to inform engagement approaches for future responses so that we have a continuous learning sort of cycle. So quickly in summary, learnings from this piece of work. Involvement in decision makers and end users is absolutely critical for ensuring relevance and building trust. They carry a lot of context with them that we might not necessarily have visibility of, and that's really helpful for kind of determining the future shape of the program or the evolving shape of the program. Working in partnership with key stakeholders is absolutely mission critical and ensuring consistent involvement from day one. I acknowledge that with respect to the Bovis program, one area where we absolutely should have done more was in honoring Te Tiriti and partnering with Māori. I could, probably give a presentation just about how hard we tried to determine the impacts of Bovis on Māori land, but that doesn't excuse that should have been a consideration from the outset. I know it can be a pain, but clear, consistent communications and reporting, and the value of that cannot be overstated. Being able to communicate what you're getting out of a technical piece of work and how it will be used in really simple, pithy language will go incredibly far to looking after your authorizing environment, your decision makers, and ensuring you can get to that next step of a program. And then finally, articulating the pathway to impact on a continual basis, knowing when to change direction or winding down, being mindful of kind of the sunk cost fallacy, and knowing when to kind of push stop on a piece of work, recognizing that we do still have kind of an evidence base that can take us so far while we might not necessarily have the original product intended. And that's it for me. I realize that was a bit of a whirlwind example on an operational space, but hopefully there are some helpful nuggets in there, and happy to take questions at the end. I will stop sharing and hand over to Barry to cover his part of it.
Thanks, Sarah.
Right, I'll just see if I can share this.
Great.
Can everyone see that?
Yep. Good one.
Great. Okay, thank you. Thanks, Sarah, for that. That was a great introduction. There'll be a little bit of crossover here, but I'm going to go down in a little bit more detail. this part of the presentation is really focused on some of the more operational solutions our research is focused on. And the first thing I wanted to point out was that science is really critical to MPI's work, particularly in achieving our vision that New Zealand will be the world's most sustainable provider of high quality food and primary products. So the scope of the presentation is really an overview of why science and science research is important to MPI. And I sort of want to give the an indication of the scope and breadth of MPI science, because even when people come into MPI as employees and employees have been here for a long time, it's really hard to get a handle on just the breadth of activities that MPI undertakes. So I'll go through that briefly and then give you some just some hand-picked examples of science in action and the impacts that it has on the targets and users of that research. So the first thing to note is that MPI is a really major funder, user and generator of world-class science and research. And we use high quality scientific evidence and expert advice to inform policy development, regulations and decision making. And as Gerald had indicated in his presentation, the science is to inform policy development, not dictate it. And that's used in various ways. So we rely heavily on the high quality of that scientific evidence and work hard towards making sure that it's backed up by robust data. And the second point is science in action. So the breadth and the depth of our science is huge, and that includes the science expertise we have in the organisation. So we have to have expertise covering areas of science relating to food safety, to biosecurity, to fisheries, animal health and welfare, agriculture, forestry, and climate change. And with the various subtopics within those as well, you can understand that the breadth of our science expertise is quite significant. Biosecurity, protecting New Zealand from threats. Biosecurity in New Zealand is a huge part of MPI, looking for pests and diseases that threaten our primary industries. The picture there is of the new National Biocontainment Laboratory at Wallaceville. That's a $100 million build, an investment we needed to put in to look at high impact animal diseases, particularly to manage incursions like foot and mouth disease if it ever got to New Zealand. So that laboratory processes about 37,000 diagnostic tests a year. And in the plant health labs, we currently identify over 100 plant diseases and 6,000 microorganisms a year as well. And that activity has a significant impact on imports coming into New Zealand, but also on the ability of New Zealand producers to continue to grow and produce the goods that they do. Fisheries, our science tells us which New Zealand fish stocks are in good shape and which need protecting. So there's an enormous amount of science research which goes on an ongoing basis to understand our fish stocks and feed into the fish quota system. Animal welfare is also a big part of our work. So the development of policies to promote the humane treatment of animals, ensuring that's underpinned by strong scientific evidence. And as many of you will be aware, New Zealand is a world leader in animal welfare policy and animal welfare research. And we're currently in the process of promoting the development of an animal welfare science strategy to try and bring together the animal welfare science from across New Zealand, because there are lots of gaps in that system. So this relates to food safety. New Zealand food safety is involved in many activities, making sure the food we eat won't make us sick, researching how to reduce on-farm emissions and greenhouse gases, and biosecurity programs like protecting natural resources through programs such as Kauri Dieback and Myrtle Rust, teaming with the Department of Conservation on matters relating to that. And we also have a strong international component as well. So we have some international treaty and so forth obligations. Our scientists interact on a number of levels with international bodies and bodies overseas. I'll mention one there called Codex, which coordinates the international food safety standards, and also the Global Research Alliance on agricultural greenhouse gases. So what science do we need? Sarah's given some indications of that. This is a 2018 document now, the Primary Sector Science Roadmap, but it still is relevant now as it was when it was put together back then. So this roadmap provides an integrated view of the science technology that's important to New Zealand's science sector. It supports the activities throughout the science system, helps guide funding and investment decisions, aligning research, development, science capability, and encourage partnerships with industry and international collaborators. And we can provide a link to that primary sector science roadmap subsequent to this webinar. This science slide is a little bit out, the figures are a little bit outdated, but I put it in there just to give you an indication of the science funding and investment. So in 2017, 37.5 billion in primary sector exports. I think that's up to over 50 billion now. 7 of the 11 national science challenges were involved in primary sector science. And there were 1,740 primary sector scientists in Crown Research Institutes alone. So those numbers, they're probably higher now, but it gives you an indication of the degree of investment. I know that MPI science funding is probably in excess of $700 million now, so we are one of the biggest science funders. So the science we do and the science we fund. Just some examples here. Fisheries research. Why do we do fisheries research? It's really essential for getting accurate information and making the right decisions. Really essential for the seafood quota system and managing our marine biodiversity, making sure that we do have fish in the seas for years to come, and to use fisheries resources sustainably. Important for increasing our productivity and exports and protecting against biosecurity risks, and understanding and responding to trends and issues. But we also have to do that research to plan for the future as well. And the research topics are really, really broad. I've just included a number there relating to the commercial fisheries, highly migratory species, rock lobster, shellfish, and so forth. And we have over 30 years of scientific research related to fisheries. And this is an example of some of that research, overcoming the challenge of distance in our food industry. Distance in terms of primary sector exports is a really important issue because we're so far from some of our key markets, and that imposes a whole lot of challenges on the ability of us to send food and primary sector products overseas and making sure they get there in a state that we want to get them to. So this bit of research focused on the processes and technologies for stress-free capture, storage, and transport relating to a number of species, particularly in this case, crayfish. And the research focused on developing insulated polystyrene boxes reinforced with a high crush but low strength, low weight steel casing for crush resistance to maintain an optimal temperature for shipping live animals to countries like China. Obviously, in this case, it's really important when you're sending live animals that when they arrive at their destination, they're first of all alive, and secondly, they're at a good, healthy condition. And those sort of innovations have a huge impact on reducing the impacts of distance to international markets. Foodborne illness. New Zealand Food Safety does a lot of research into foodborne illnesses, as well as undertaking a number of investigations into those cases when they arise in New Zealand. So a lot of that research focuses on reservoir and source attribution, better methods of typing and determining what is the cause of those foodborne diseases, understanding the baselines of food and environmental surveys, and predicting models, as well as educating people on how to avoid the cases of those foodborne illnesses arising. And there's also quite a lot of research focusing on the assessment of risk for those biological hazards as well. A lot of people don't know that we do a huge amount of bee disease research. This is largely based out at the the Wallaceville Animal Health Disease Centre in Upper Hutt. And we have a small team there, but a very significant team who's made huge inroads into coordinating and investigating bee disease research in New Zealand. And bees unfortunately have a large number of diseases, many of which we don't have and which we don't want to have. Unfortunately, we do have some significant bee diseases. One of the most significant is the varroa mite, which is shown in the picture there. And varroa mite is still causing a huge amount of grief to beekeepers in New Zealand, even though it's been in New Zealand for over 20 years. So based on current reports, from 41% of our beekeepers managing 49% of New Zealand's honeybees colonies, the overall loss rate during winter last year is about 13.5%, and that equates to about 98,000 colonies. So that disease is having a huge effect on bee and bee product honey production in New Zealand. And there's a huge amount of research being done, particularly in collaboration with research partners, to determine better ways of managing varroa and to reduce the colony loss rate, which unfortunately is still increasing. Interestingly, our bee research people out at Wallaceville have just been recognised by the World Organization of Animal Health as a international reference laboratory for several bee diseases in New Zealand. And that's the first time that's occurred in New Zealand. It's a really huge achievement. Cyclone Gabrielle, I'll mention this in particular because of the occurrence of this event and the significance of the event and the effect that it had on the primary sector. It's a really good example of understanding why science and science research and the information relating to specific aspects of that event was really needed urgently in order to inform government decisions. These pictures here are just some examples of the degree of impacts that it had on various parts of the primary sector in Gisborne, East Coast, and the Te Rāwhiti area. So, I mean, Gerald and I in particular did a lot of work on trying to determine information around the impacts of sediment, the impacts of waterlogging, particularly on pastures, on orchards, and vine recovery. And this was urgently needed in order to inform government policy and funding decisions. And interestingly, even though we've had a lot of these events previously, a lot of the information gaps, we didn't have a lot of information in some of the areas we had. So we had to really call on the advice from a lot of our research partners, including the Crown Research Institutes, Plant and Food, Landcare and so forth, just to try and get information relating to how best to manage the impacts of this event on trees, on grass, on grapevines, on a whole range of horticultural products, just to get some measures in place and get some advice out there to help farmers and growers alleviate the immediate risks related to this. So that translates into a lot of research funding. And I just highlight a couple of areas of funding that have resulted from the setup of our extreme weather division within MPI. So several areas that have just been funded as a project to examine the effects of Cyclone Gabrielle on marine habitats. As you know, there is a huge amount of sediment which was released into the east coast waters following Cyclone Gabrielle, a massive amount of sediment. We don't really understand the effect that has on marine habitats in the short and the long term. And even though there was a lot of sediment released from Cyclone Bowler, the information on those marine habitats from that is still pretty weak. So there's been an investment of about $1.9 million from MPI to try and understand the effect of those sediments on marine habitats and fish take and so forth. The second one I've identified there is $75,000 worth of funding to analyse and better understand the impacts of Gabrielle on the abundance and distribution of rock lobster. So some of these funding areas are quite specific. We co-join with industry partners in some of this research, but MPI is supporting areas of research like this in order to understand future impacts and to put mitigations in effect for future events. Sarah talked about Microplovis eradication. I just wanted to highlight a couple of bits relating to that. No one in the world's been able to eradicate M. bovis. So New Zealand took on a huge challenge when it put out the huge amount of funding to try and get rid of it, and we're pretty close to it. The real problem remains around asymptomatic case detection. So, and Sarah indicates some of the research that's been underway for M. bovis. The one I wanted to focus on is the research has been funded by MPI to identify biomarkers for early diagnosis, and that's in order to crack that difficulty relating to detecting asymptomatic cases. If you can't crack that, it's going to be very hard to eradicate the disease finally. But that's just one example of research funding which is being put in to try and get rid of those last cases. We do a lot of work on plant disease diagnostics and in post-entry quarantine. A lot of that research is focused on faster disease diagnosis, so particularly so that when plants which are imported into New Zealand have less time in post-entry quarantine, and also helping to reduce the cost to importers. For some of our high quality and high risk plant species such as grapes, they can spend up to 5 years in quarantine. Importers have to pay for that, and they needed to go into quarantine in order to go through several cycles of growth so that various diseases can be detected to make sure that they're not present. And so a lot of work is focused on reducing that through that time for faster and more accurate methods in order to reduce cost and get them out of post-entry quarantine as fast as possible. This is just one example of some of the research that's been undertaken by one of our people based in the Plant Health Laboratory in Tamaki in Auckland. Real-time PCR and HD detection of selected regulated and emerging plant viruses impacting New Zealand high-value crops. In this case, a lot of it is focused around citrus. So work like this can have a huge impact on getting imported plants, new genetic varieties into the New Zealand environment and into commercial production faster. So look, those are just a few examples of some of the research we do and that we fund in order to make significant impacts to the primary sector. Hopefully I've given you a bit of a flavour of the breadth of science that we do. It is really, really broad, covers a huge amount of areas. But the things I do want to highlight is that science, the science that MPI does and the science that MPI funds is really critical to MPI's work. There's a huge amount of areas I haven't covered, but hopefully that'll give you a flavour. We're a really large science funder. I think it is in excess of $700 million a year. We rely on high quality scientific evidence and expert advice to inform policy development and regulations and decision making. And our research, and particularly as you read that primary sector roadmap, the research needs are both immediate and they're long term, and we have to plan for that. And really the impact of science for MPI is ensuring that the primary sector is and remains the engine that drives the economy and people's well-being. So thank you for that, and happy to take questions at the end.
Thanks, Barry. Gerald, you're lucky last, which means you also get the time crunch put on you ever so slightly. We've got 22 minutes left. Your presentation, though, covers some really important stuff. So I think if you're happy just to try and speed through your slides at an appropriate pace that doesn't gloss over some of the key points you've got, we might still be able to steal just a few minutes at the end for some key questions. But otherwise, over to you, Gerald. Looking forward to your slides.
Okay, Paula, have you got them there? Good. Now, Paula's going to load them for me and move them forward. Firstly, I'd like to take your indulgence of actually going back and doing a bit of history. Basically, I worked out the other day, I've been in the science system covering all sorts of areas for 47 years now. So I will give you some old work that we have done, but reflect on how it's actually used now. I want to go back and reflect on an important Maori saying in this area, ka mua, ka muri, looking back in order to move forward. So that's what my reflection is here basically as well. Okay, Paula, are we ready to go? You're right. Can't see anything, so
Gerald, I'll jump in. I'm back up. There we go.
Okay, if you could good expand that. So the next one. So I want to talk about some of the early research. Look, if you're going to make put evidence into policy, you might as well go to the very top. And some of the probably unique work that we did back in the turn of the century, I suppose, is some work that I was involved with in Morst with Dr. William Smith, where we're looking at cabinet papers and what evidence was actually going into cabinet papers. And that's the ultimate, basically, in any decision making in the country, basically. And it was interesting, some of the results. Now, we reckon that 50% of the papers needed more evidence, but only half of them were actually getting that evidence. And ministers were really keen on getting some more evidence in a wide range of papers as well, with big differences between the cabinet committees and also the departments, not unexpectedly. So I think that's important. If you're going to the top, they want some science evidence into policy. Next, please. Okay, some of his conclusions, basically in 3 areas: strategic, human resources and funding. Strategic, strengthening the procedures to anticipate early policy needs. In other words, we need a lot more foresight in terms of what's coming up for science, because science takes a while to do, and it's time that's of the essence, basically. So more foresight. Human resources, we need some institutional memory, and that's probably a reflection of the turnover, which is probably even worse now in government departments than it was in the past, and even in science institutions. Networking also needs to be fostered. We need to build a culture of science for policy advice, and scientists and policy people need to gain some more experience in providing that information. And lastly, funding. Everybody, you can't do anything unless there's some resources there in terms of actually doing that work and providing that to the relevant party. So external funding, both the departments and actually to commission work, but also for the science system to put work into into the relevant areas. Next, please. So Professor Sir Peter Gluckman has probably had a large amount of influence in more recent years about looking at science into policy. This is just reflecting some of the key features that he actually found around evidence-informed policy. But he's continuing this work in his new role, leading this international group that he's involved with. But, you know, quality and accessible data is needed, robust collection of that data and the instruments to actually collect it. Awareness of all the analytical assumptions. We need to understand that and the theoretical perspectives that underpin a lot of the research methodology. Understanding the limitations of the work is even when you're looking at robust evidence, and also looking at the expectations of certainty and managing uncertainty. Now, this is probably the weakest part of most of the advice going up to ministers on that. How do you reflect certainty and uncertainty in what happens? Now, this is just to go to show that MPI has looked at evidence in the work it's done. We did a survey in September 2013, 10 years ago now, if we can keep going. Okay, what do we get from our survey? This was a internal survey looking at all the different parts of MPI. We asked if they had any significant gaps in the evidence, and they said yes. Do you commission evidence? They said, the majority said no. So those two don't sort of balance out, do they? They recognise the fact that there are gaps, but they're not actually commissioning it, and we'll talk about some of the reasons why. Next, please. We looked at, you know, what counts as evidence, and we went around our list. It's actually interesting to see. That's it. We can actually see the sorts of areas where they had the most confidence about getting their information from, what they classed as evidence. Researchers, other government departments, journals, internet being the top ones, lobby organisations, general press. There's been a bit of discussion around lobbyists these days. It's good to see perhaps that they're not considered as relevant for evidence as other parties. Friends and colleagues and conferences as well. The importance of conferences is probably important now because of this issue of travel and going to international conferences, because we are at the bottom of the world and it's pretty hard to attend them these days. Next, please. Okay, if you can go to the next one. There we go. Okay, what are some of the obstacles of actually the use of the evidence? So we've looked at the sources. What are the things that reflect its use? And we've seen, you know, the fact that people have identified gaps. So timing pressures. There's always time pressures on people when they're doing policy work, whether it's the next day or the next week. It's not, the timeframes are different from what science timeframes are, and that needs to be reflected. The lack of access to the necessary tools and databases. And it's even interesting now that we don't actually have access to some of the large databases. We have to commission papers and that from our library resources. The lack of access to the workload involved internally, and how do you reflect that when you've got heavy workload? How do you devote the time, once again, to put into getting the information you need? The access and the funding to commission, once again, has come up as one of the key obstacles. So, you know, there's reflection of the earlier elements around the evidence needs. Do you reject evidence? And I think this is an important point. You shouldn't believe everything you read. And how often do you actually reject the evidence that's presented to you, whether it's high quality or not? You can see that the majority of people in this particular case didn't reject evidence. So that's an issue in its own right that we could discuss further. Next, please. Evaluation of the evidence. Do we do any evaluation of it? And you can see all the impact of evidence. And the majority of evidence that's used and put forward is not evaluated to its effectiveness. And this is, I suppose, what this group's about, essentially trying to stress the importance of this and what it means. And people weren't even planning to evaluate their evidence that are put forward at this stage, because it's normally at the end of the financial year or the end of the budget process that the evaluation goes into a project, and it's little is available. Okay, if you go on, please. So one thing that's been mentioned several times is the issue of science quality. And it's important that this is reflected in the contributions to policy. You can have a look on the web and there'll be as many definitions of science quality as there are links. And this is my one, which I thought reflected probably the best way of looking at science quality, particularly in the physical sciences, means a measure of excellence or state of being free from defects, deficiencies, and sufficient discrepancy, and is conducted rigorously and systematically. Those last two words are probably the most important. But I also thought it was useful to reflect what is the characteristics of a scientist who you would actually would deliver quality science that you would see, and what would you attribute to their characteristics. And there's a reflection of a whole range of traits you might expect in a sort of rigorous and systematically delivered science quality for a scientist. The issue with policy people, if they need to quickly evaluate something for a policy perspective, what should they look at? If they have thousands of papers or tens of papers on a topic area that they're trying to quickly get an estimate of its quality. So here are some of the characteristics. Once again, around the organisation, around the group, the quality of the data and how it's gathered, how it's measured, how it's analysed, and also are the conclusions justified? I think that's a key factor. Okay. This came up, this is a paper from Nature that actually I read last week. So if you think this is an issue for the past, this is happening now. So the title was How Many Clinical Trials Can't Be Trusted? And from the analysis in this paper, they believed 25% of clinical trials were either problematic or fake, or the new term, which I hadn't come across before, called zombie trials. Basically, they don't exist in reality. They urge a stronger scrutiny. So the whole issue of scrutiny of what you're reading and putting into policy is really important. So what MPI also does is that we actually have an assessment of about 60 to 80 policy papers every year by NZIER. And what we've done on a couple of occasions is looked at those papers also from the point of view of the science evidence within them. And you'll see that those which had science evidence were graded by NZIER assessors as actually having higher quality than those without. So that was in 2013. We go to the next one, please. We did this again this year just to see what the difference was. And we see, luckily, that we're still holding up here, and that those with science evidence, those policy papers, have been judged as having a higher quality than those without. Okay, let's move on. Here are another couple of papers that I've come across over the years, which I believe are really useful for those actually assessing science from a policy perspective and what scientists need to think about in terms of what they're doing. 20 tips to interpret science, and also standards for evidence and policy. We could just go to the next one. I'm not going to go through those 20 tips there, but you'll recognise all of these things about, no measurement is exact, and regression to the mean can mislead. Correlations do not imply causation. These are all factors that people are well aware of, but they need to be assessed if you're actually looking at policy, putting science into policy. But I thought the final comment there was really relevant. The final question to ask is, what am I not being told? This is if a policy person is talking to a scientist about some specific work. Okay, let's move on. And the other paper gave what I thought was a really useful framework on how you might consider both scientific papers and also policy papers. And I reckon each paper should be assessed with this criteria, really. So it's got 11 different grades. At the 0 grade, it talks about the paper being just about a theory that's been proposed at that end. So you've got a paper, it's a theory, you're putting it into the policy process, and that's all it is. The last one, number 10, says, look, this work has been tested dozens of times. The results are consistent across the board, and therefore, we can be pretty certain if we use it again, it's going to work. and actually judging all of the papers going forward, and that means I think would be quite useful. Okay. I thought I'd give a bit of advice for a career in science. If anybody's considering a career, this is my learnings over the years. These are the sort of characteristics you need: intense curiosity, supportive mentors, patience and persistence for all the tedious work done. Science is not all about making breakthroughs. Resilience for all those ideas that didn't get funded. I see each funding round, we get a lot of emails coming back to us that are pretty sad, really, because we thought we've supported some of the research. What I call bloody mindedness to stand behind the results produced. If you believe in them and stand behind them. You need a sense of humour as well to get through all the days you question why you are here. The ability to present your work and make it interesting. I think that's really important. We see that in PowerPoints these days. And finally, address real world problems that make the world a better place for all. So that's my experience from all those years in the science system. Okay, next. Few conclusions: explicit requirements from government, commitment to organisation, science culture, need for standards, use quality science, less media, more journals, reduce time constraints, and do more evaluation of that work. That would be my summary of what the reflections are on science into policy going forward. So last thing, anyway, so the take-home message, I believe, you need to move from you don't know what you don't know what you don't know and actually seek help or evidence to actually prove the elements you want to take forward. So quality science used well. It isn't easy, but we can do better. That's me. Thank you.
Thank you. Thank you so much, Gerald. That was great. I loved your advice for a career in science. It was lovely. I'm going to be diplomatic and go on the order of the questions as they've come up in the chat, putting aside some of the commentary around beekeeping, which is a conversation as an amateur beekeeper. I'm very tempted to join in as well. Helen, Celia, this was a question directed at you, Sarah, in the first instance, but the three of you might all have some perspectives to share around how MPI is reporting on the uptake of research from its programs. And Helen was interested to hear about how the funding is split, and if there's actually specific expectations or rules or something about the activities required to support what's effectively some of those translational activities as opposed to the doing of the research piece itself.
Yeah, I think probably noting that my example was very, very strongly in the operational space. Read the funding split. The way we kind of overcame the translational thing was having the people who could do the translating involved from the outset. So in terms of the problem definition and the procurement of the research and then the delivery of that research. So for us, that was a really critical element of it. And a more non-operational space, that's probably an area where you see things falling over quite a bit, is that you do so much upfront focus on the technical science and you don't actually have that translation element. Like, it's a huge chunk of what our team does is translating some of those complex topics into things that could be understood by a layperson. So I mean, I'm not sure if I'm entirely answering the question, but I would say that that's an area I'd like to see more dedicated funding toward, and it's one that as government funders we need to be more cognizant of funding because it's such a critical part of the pipeline that I think often gets overlooked because we get so excited about the bright shiny technical thing.
Barry and Gerald, did you want to add anything?
Yeah, look, I think the other thing is though that MPI is moving forward in this area because we have got the on-farm services team now, which will have a key role in basically taking some of this stuff forward, and they have employed some science extension translation people as well to do that. But also our contracts tend to have quite specific requirements about actually putting the information into a usable form and running workshops or whatever it is, or presentations that, not to the extent we'd like it. And the main issue is to do that on an ongoing basis because the information doesn't come stale overnight. We need to continue to repeat what we've got out of that stuff. So I agree with Sarah, we don't probably do enough.
Just in the interest of time, I'll go on to Daniel's question, which I think is actually a bit of a segue around the focus on impact and continuous improvement. And Daniel was quite keen to hear about what does that concept of continuous improvement mean for MPI, and so how do you support it? So it's kind of like those supporting activities, much like the translation piece we were just talking about.
Stone silence. I think that the continuous improvement relates to how we change the ways we do things over time. We do look, there's quite a lot of evaluation studies of each of the funds. You know, it might be after 5-10 years that each of the funds have been evaluated at least 2 or 3 times. I would have thought about their effectiveness, how they operated, how we determine priorities, who should be there, how we put it into the system for it to go forward. So there is ongoing improvement over time for virtually all of the funds, and policies change and how we do them. You know, you can guarantee that the name of the fund will change quite regularly going forward as well. So there'll be new policies around how it is funded.
Yeah, I think, and we have, this is one area where we have gotten better over the years in terms of the direction, delivery, uptake, and review of the science, and keeping sight on that cycle so that we can kind of reflect back on what's worked well and what hasn't. Yeah, from a continuous improvement perspective, there was something else I was going to say now. It is completely escaped. Oh, capturing lessons learned, which is, again, something that we're starting to do a bit more in the response. So what worked well, what didn't work well, and putting it down on paper in a discoverable format so that it's not on the heads of people who are involved in those pieces, and then they leave the agency with that institutional knowledge, and being reflective on that as a process.
Yeah.
And
Barry,
look,
did you have anything? Yeah.
I mean, continuous improvement goes on all the time in a number of areas. And we do a huge number of surveys, you know, particularly out to people who are the recipients of our research and the end users of that research, to try and understand how we can do things better. You know, and those are constantly put into ongoing review of strategies, of programs, of responses, particularly in the biosecurity space. Biosecurity models are constantly being revised based on experiences that have from incursion and responses relating to that, and as the science comes in, because there's always more information and knowledge coming into the science system, and we capitalize that as much as we can. It's a resource heavy area, but you know, it is a focus. We could always do more, of course.
Yeah. It's 1 o'clock. I appreciate that some people are going to have to drop off. We do have a couple of extra questions. If you if the 3 of you have a few moments to spare, we can hang on, and then people can actually watch the recording back for the final parts. But for those of you who do have to drop off, thank you so much for joining. And as you know, that we will be sharing the recording. But given the interest, it'd be great to just try and cover off another couple of questions here. One of them, if I'm just going to scoot down a touch, there was one from Scott. A question for you, Gerald, was around what could scientists or the science system do to assist in overcoming the obstacles for using evidence? And I'm thinking, like, there's good guidance within the government around things like the policy project, telling policymakers to use evidence. But yeah, so what could scientists be doing to help that process?
Yes, I think the best way is that if organisations designate probably people within their things that have a very close science policy interest and links. Over the years, it's interesting because there have been certain individuals who I've always gone to because I know they understand the science policy interface. And it's not an easy interface to actually understand, and actually getting people who are familiar with it and understand both sides of the equation, of the political imperatives, the timeliness imperatives of work, basically. I think that would probably be the most rapid way of actually advancing it, because even now, you know, we're talking about hours and days for turnaround for material, and that's not quite what most scientists see as their timeframes for stuff. So even understanding that is really important.
And actually, Gerald, if I could give a plug, back for the webinar that we ran previously 2 months back, because we didn't run one during the June, which is always a horrible time of year. And we had a particular focus on policy, and that was a big part of the presentation, and how to Hen McKercher has developed some good tools and templates.
Yes, that's right. Yeah.
And George Slim was also talking about the tightness of that time frame and how to bring yourself closer so you can be more in a position to respond at the moments at which the information is actually needed, because it does operate on quite different timescales often. Yeah, so I'd encourage people to have a look at that as well. One last very quick question, just from Nicola, about involving decision makers and end users from the outset. This is for you particularly, Sarah, around the co-creation process. She was asking, was there any co-creation of science projects with the scientists themselves to ensure the projects would generate information needed to ensure impact? Or does the research procurement process actually make this difficult?
I mean, it does make it difficult, but we have to recognize we're only so big, and it's really hard to have a science program within New Zealand where you don't have people are conflicted, and so you have to be really careful about managing those conflicts of interest. So, for example, we held those workshops, those 2-day workshops, where we brought in all of the technical experts that we could get from across the country to feed into those processes, and ultimately some of those scientists would have bid for some of the contestable pieces within the portfolio. But what we also tried to do was keep the SAG just a bit of a step removed from that, so that we still have technical experts who are providing advice to us on the delivery of the portfolio, but in a way that kind of protects us a bit from that potential conflict of interest. I mean, it can be done. We're too small for it, to completely avoid it. You just have to manage it very carefully and be very deliberate and upfront about what you're doing.
And actually, to go back to some of what you were saying earlier, it sounds like you've got quite a number of kind of nested loops feeding and backwards and forwards, like the road map and so on. So there's opportunities for some of that, those conversations, perhaps to sort of filter backwards and forwards through those kind of more micro to the macro decisions and guidance that's happening. Would that be right?
Yeah, that's right. I mean, the being cognizant of where all of those things intersect and how they play together is obviously incredibly important in that.
Great. All right. Well, look, I want to say a huge thanks once again on behalf of the iPEN team for coming and sharing your insights and how MPI does think about research impact and supporting it, because that's really what that's why you would bother. That's the why bother, because we want to see things get better and change. So yeah, it's really great to hear that. And if anyone has any questions, you're still welcome to flick them through. We can pass them on. I hope it's generated a really useful conversation. An interesting segue to this notion of continuous improvement. Next month, our webinar, which is going to be featuring some of our PFR colleagues, are going to be talking about how they've bedded in a systematic approach to review and reflection into their project, and how that's actually helping to support impact from that. Which is also a lovely segue to a new workshop that iPEN's developed with a tool to help support actually sort of hardwiring some of these processes into your projects. So we really hope to see you next month to hear more about that. But otherwise, thanks again for hanging in there for a few extra minutes. And thanks once again to Gerald, Barry and Sarah. It was incredibly grateful to have you along, and would love to have you back if you've got anything else that you think would be good to talk about. Otherwise, ka kite anō everybody, have a wonderful rest of your day, and I hope the sunshine finally arrives to some of you later, as it's beaming on my face today. Ka kite anō everybody.
Cheers, great to see you.